Hey guys, just to let you know, this lesson is in collaboration with Flip Academy, a free online platform for all of your GCSE, A-Level, IB and CBSE revision, out now on web at www.flip.academy, and also as an app for Apple, iOS and Android. It really is better than all the other GCSE platforms out there. It covers all the topics in great depth and has an app that you can download your courses on and use offline.
Hello and welcome to Flip Academy. Today we're going to be looking at the CIE A Level Maths differential equations topic today. So the first spec point is to formulate a simple statement involving a rate of change as a differential equation. So we're going to see quite a few examples of this a bit later on in the lesson. But essentially they may say something like, y is proportional to the rate of change of x with respect to time, and then you'll be able to formulate either formulating a statement or formulate an equation itself. So these questions, just so you know, with differential equations, they're pretty long and they're pretty tricky. So we're going to take this nice and slow, but keep in mind these are like 9-mark questions. They're quite big, they're quite beefy. So we may need, you may need a bit of time to kind of get used to it. Okay, so find by integration a general form of solution for a first order differential equation, in which case the variables are separable. And I'll go through exactly what that means in 1 second. So here we have a chemical reaction. A compound X is formed from two compounds Y and Z. The masses of in grams of X, Y and Z present at time t seconds after the start of the reaction are X, 10 minus X and 20 minus X respectively. At any time the rate of formation of X is proportional to the product of the masses of Y and Z. So if you have a look here, the rate of formation, so it's the rate of change of the mass with respect to X, which is where the dx by dt comes from, and it's proportional, so these two things times together. And it says show that X and T satisfy the differential equation here. So a few different ways of doing it, but the best way to do it is they tell us that it's proportional to the product of masses X, Y and Z. So the best thing to do is to just write out the equation again, but with the proportional sign. If you remember, to get rid of the proportional sign, you have to introduce a constant k, which is exactly what we're going to do right now. And now we need to work out what the value of the constant k is. And we should find that it equals 0.01 because that's the answer to the question, right? So here we have dx by dt is 2 when x equals 0. So we're just going to sub in those two values. So what we can do is create a little bit of space for ourselves here. So we have 2 equals k, 10 minus 0, so I'm just going to write 10, 20 minus 0, so I'll write 20. So we have 2 is equal to 200k, so k is equal to 2 over 200, which is 1 over 100, which is indeed 0.01. So because we got the exact same form here through using the information here, it must be correct. Okay, now here's for the fun one. So here's going to be the lion's share of what we're going to be doing today, is solving differential equations, which is the primary thing that they want you to be able to do in the kind of CIE A Level Maths in terms of this topic. So solve this differential equation, obtain an expression for x in terms of t. So this is quite long, 9 marks, so you can expect that it's going to be a bit tricky. So what we're going to do here is we're going to rewrite the exact same equation again. So that's what I'm going to do, okay? So dx by dt equals 0.01 We're rewriting the exact same thing again. Yeah, cool. Now to solve differential equations, what we're going to be doing, and obtaining expression for x in terms of t, is if you want to find x in terms of t, you can probably tell we need to integrate this thing, right? Now, to do that, we need to do something called a separation of variables, which is what the previous spec point said, right? So variables are separable. So what that means is everything with an x has to be on one side, everything with a t has to be on the other side, or whatever variable. So later on we have one with x and y in it. So we have to just separate the variables to different sides of our equation. So what I'm going to do is I'm going to move this stuff, which is all to do with x, to the left hand side. So to do that I'm just going to divide by 10 minus x, 20 minus x. So I'm going to write it. I'm going to write it like this just for now, and you'll probably see why in a second, because I think it's a bit clearer. And again, I'm leaving dx on this side because dx is part of x. And dt I'm going to move up to the other side. There we go. Now the reason why we do a separation of variables is because we can integrate both sides of this expression now. And that will allow us to solve the differential equation and get our expression. You can't integrate by two things at once, okay? So what I mean by that is I can't just keep the x's and t's on one side and just integrate all of them at once. It will not work, okay? Because again, if x depends on t or t depends on x, which they do, x does depend on t, then we can't integrate like that, okay? So we need to separate them, and it just means we can integrate them separately instead of doing kind of compound integration and things like that. So what I'm going to do is I'm going to make some more room, and we're going to basically be writing to the right, okay? And this is quite a long question. So first things first, to integrate this, we can't actually do it straight away. We have to use partial fractions, okay? So what I'm going to do is I'm going to basically separate this out. In order to do partial fractions, we're going to have on the left hand side this, and that equals a over 10 minus x plus b over 20 minus x. Okay, then we times through by the denominator of the left hand side, so 10 minus x, 20 minus x. So on the left hand side we're left with 1. Now if we were to times the whole thing here by 10 minus x, the 10 minus x is cancelled, so we're left with a 20 minus x plus b 10 minus x. And then solving this should hopefully be relatively okay. So what we need to do is sub in values that will cancel out one of our unknowns. So for example, if I sub in x equals 20, this first whole thing here becomes 0, so I'm just left with b, which means I have one unknown, which means I can solve it. So that's exactly what I'm going to do. I'm going to sub in x equals 20. Left hand side is still 1. A goes away, so 10 minus 20 would give me minus 10b, which means b is equal to minus 1 over 10. Then if I sub in x equals 10, I'm left with 1 equals 20 minus 10, which is 10a, and again the b stuff goes away, so a is equal to 1 over 10. Okay, so far so good. And again, there are a few integration tricks I'm going to be showing you throughout this video, so feel free to write them down and make sure that you are familiar with them because they come up again and again. Solving differential equations, we're quite lucky because they actually come up in similar forms. Okay, so they're always, generally speaking, similar to each other. So the tricks I show you are used in most differential equation questions. So now I'm going to sub it back into this original expression we have here. So instead of 1 over 10 minus x blah 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 blah, what we're going to have is 1 over 10, or rather we're going to have, actually I'll leave it as 1 over 10. It was 1 over 10 minus x. There's a reason why I'm writing it in this perhaps slightly strange way. So can you see that this is just where a and b are 1 over 10 and minus 1 over 10. I'm leaving these fractions in front because if I combine them into the fraction it can be a bit confusing. We're going to put them outside of the integral sign. And that's all with respect to dx equals 0.01 dt. Now what I'm going to do is I'm going to now integrate both the left and right hand sides. The left side is with respect to dx because dx is there. The right hand side is with respect to t because dt is there. So I'm going to now pull out the 1 over 10 in front. Okay. And we have 1 over 10 minus x minus 1 over 20 minus x dx. Now the right hand side is just going to obviously be 0.01 t plus c. Now I'm going to, once I integrate this side, I should technically have another constant of integration, right? Now the interesting thing about constants of integration is that when we combine them they just become a new constant. So I'm actually going to leave c as my constant of integration, so I won't do one on the left-hand side. So you might think there's a mistake in the video. There's not. The reason why I'm doing that is, let's say I integrate this side, I get plus d. I move that and I get c, and then move it to the other side, I get c minus d. That's a new constant k. But the thing is, I can just call them all c, right? It doesn't actually make a difference, but they won't cancel out. The plus c on the left-hand side is different to the plus c on the right-hand side because it's two different integrals. So basically this c is going to cover the c on the left-hand side as well. It doesn't make a difference. If you want, you can introduce a new constant of integration, d, but then once you can combine those into a new constant, right? Because they're all just numbers. It doesn't make a difference. Now on this side, this is where things get a bit interesting. We're integrating 1 over this, and you might think that you know how to do that. But here is the actual kind of official way on how to do that, because it's not just ln x, right? It's not just that. Technically speaking, so this is going to be a bit of an aside, so I put it in little square brackets. If you integrate 1 over a function of x, it gives you ln of that function over the differential of that function. So sorry, I meant it's not just ln 10 minus x, that's what I meant to say. Okay, so that's the first integration trick. It comes up all the time, so I would 100% recommend you know, remembering it. So 1 over 10. Now I'm going to just write it out. So what we have here is we're going to have, let's put this in brackets, ln 10 minus x in brackets over, if I differentiate that, I get minus 1, right? Minus, again, ln 20 minus x over, if I differentiate that, I get minus 1. And now again, I'm not going to write the plus c because I'm just going to combine it into, you know, my big constant c on the end, okay? Now, obviously this minus and this minus will cancel out, right? And the next thing I want to do is I'm going to times both sides by 10 in order to get rid of the fraction on the left. And one more thing I want to say is I'm also going to write, so this is going to become minus ln 10 minus x, right? So I'm going to write the ln 20 minus x first, minus ln 10 minus x, just to make my life a little bit easier later on. Equals, so I've multiplied by 10, so this becomes 0.1t, and I'm going to call that 10c, it doesn't actually matter. Now, I need to work out what my constant of integration is, so what I'm going to do is use the original part of the question, you know, when t equals 0, x equals 0, okay? So I'm going to have ln 20 minus ln 10 equals 10c. ln 20 minus ln 10, and this is where the rules of logs come into play, is the same as ln 20 over 10. So in other words, it equals ln 2 equals 10c. So my constant is ln 2. So now I'm going to write this out again, but this time I'm going to combine these two logs, because this is where I'm actually going to... So I've done my solution, right? But now I need to write an expression for x in terms of t. So what this means is I need to get x equals and then a bunch of stuff that has t on it. But the only x I can have is on the left-hand side. So let's go. I'm going to write this out. ln 20 minus x over 10 minus x. Right? Because again, rules of logs. If you subtract one log from another log, assuming they have the same base, so all ln's have the same base, then all you do is divide them. So it's this over this, because there's a subtraction. And that equals 0.1t plus ln 2. So what I'm going to do again, so we're going to go back up, is I'm now going to move over the ln 2 to the other side as well, because that will allow us to combine it as well. So ln again, with logs, you're trying to get rid of all the logarithms, right? Because currently it's holding our x hostage. So we need to combine all the logs into one thing. So what this is going to do is I'm going to divide by 2 now. So the best way to write this would be 20 minus x over to 10 minus x. I wouldn't expand the bracket just yet because we don't know what we're going to get. Okay, cool. Now what we do is we do something called exponentiate, or you can call this raising everything to the power of e. So we're going to put everything e to the power of everything, okay? Now, if I raise ln to the power of e, it just gets rid of the ln and the e. So I'm just left with 20 minus x over 2, 10 minus x, okay? Equals e to the 0.1 t, okay? So again, this I would have e to the ln 20 minus x to blah 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 blah, but because I'm raising ln from e, it gets rid of both of them, okay? You can think that they just cancel each other out. So basically I'll put e to the power of this, so both these things just cancel, okay? That's one way to think about it. Times both sides by the denominator here, because we don't like fractions. We get 20 minus x equals e to the 0.1 t. Since we've got a 2, we're actually going to put 2e to the 0.1 t, 10 minus x. Now you want to expand the brackets. 20 minus x equals 20e to the 0.1 t minus 2x e to the 0.1 t. I'm going to bring everything with an x to the left hand side and everything with a number to the right hand side. So I'm left with 2x e to the 0.1 t minus x equals 20 e to the 0.1 t minus 20. We can factorize out the 20 if we so choose, which I do so choose. And we're going to factorize the x out of the left hand side. So if you ever have multiple terms with your like x or whatever you're rearranging for, bring them all to one side and you can, generally speaking, factorize them out. Assuming that they're not part of like an exponential or a logarithm, you can do that. So that's definitely what you want to do. But even if they're part of an exponential or logarithm, bring all of the exponentials and logs to one side, and then what you can do is just do the inverse operation. So lastly, we are finally done. Whoops, e to the 0.1 t minus 1 over. There we go. So for 9 marks, just so you're aware, probably about a page and a half of work for 9 marks. But even with me explaining it, I don't think that took much more than 9 minutes for the mark a minute. But pretty hefty, I think. For part C, it says state what happens to the value of x when t becomes large. So some of you may be able to just look at this and tell me what happens, right? Some of you. But what I'm going to do is I'm going to kind of make it a bit more, explain it in a bit of a bigger way. So I'm going to actually bring the answer over here, because again, they don't give you much space to do this, because technically speaking, you only need a line, right? A single line of working out. So, part C, we're looking for when t becomes infinite. That's what very large means, effectively. So what I'm going to do with my thing of x is I'm going to divide the top and bottom of the fraction by, so I'm going to divide top and bot by e to the 0.1 t. And what that will do is it will simplify our answer. So again, if you're eventually you'll be able to just look at this and get the answer, but this is the explanation for those of you that are in need of extra help with this. So everything in the brackets is now divided by 0.1 t. And the bottom, right? So now what we can do is we can actually cancel these down. So I'm going to write out again. So we have x equals 20, 1 minus 1 over e to the 0.1 t over 2 minus 1 over 1t. Now, if I make t approach infinity, then e to the 0.1t also becomes infinitely large, right? Because as t increases, this power increases. If it's a positive exponential, it's just going to keep going up and up and up and up and up. Now, if you notice, I have 1 over e to the 0.1t. So what's happening here? Well, the e to the 0.1t is getting infinitely big. Now, what's 1 divided by infinity? Well, it's approaching 0. Okay? Which means x is going to approach 20, 1 minus 0, over 2 minus 0, which is just 10. So your actual answer for this is that when t becomes large, all you'd have to do is when t becomes infinity, x approaches 10. Okay? So again, we're not saying that it'll actually reach this value, because of course 1 divided by anything can never be 0, right? It's going to be infinitesimally small. But we're saying it's approaching 10. It's getting closer and closer and closer to 10. Even if it's asymptotic, it's getting closer. And that's it for the first question. So 1 plus 9 is 10, 11 marker. Pretty beefy. Now, we actually did these 2 spec points in the previous question. So use an initial condition to find a particular solution. So we kind of did this back here. So we formed an equation and then we solved it using the initial conditions. Right, when we subbed in t equals whatever, x equals whatever. Right, to find the ln2 bit. So, where was that? That was here. Okay? Interpret the solution of a differential equation in the context of a problem being modelled by the equation. So again, when we did this thing here. Right, because what that means is as time continues to go on, x, which is the mass of some kind of compound, right, is going to approach 10. Okay, so that's basically the maximum amount of product they can ever form. That's all they're really asking you to do. So now, because, you know, I like to torture myself and torture you guys, I've got 2 more questions with solving differential equations to kind of give you a little more context into what you need to do. So the first one is this, and it's a 6 marker, so you can kind of expect that it's a bit easier. Find an expression for y in terms of x, but no logarithms. Now, this doesn't mean you can't use logarithms to get to your answer. It just means you can't have logarithms in your final answer. So, again, what we're going to do is separate the variables. I'm going to bring x to this side. Why? Because when you have dx or dy, they can't be 1 over. Okay? Now, for those of you that are really advanced in maths, you can kind of have 1 over, but for A-level maths, make all the dx's up top. So if you have to times by dx, then dx is on this side, y's are on this side. And if you divide by y, what you're going to get is you're going to get 1 over y dy equals 1 minus 2x squared over x dx. Okay. Now we're going to integrate both sides, okay? So integration sign, integration sign. Now this one should be fairly easy, right? If you do this, you have ln y over 1. So I'm just going to get rid of the 1 because there's no point in having it, plus c. And again, I'm going to combine my constants of integration. Now the right hand side's a bit more interesting. What I'm actually going to integrate is I'm going to separate this out. So 1 over x minus 2x dx. So this leaves me with ln y plus c equals, again, ln x over 1, so ln x, minus 2x squared over 2, so minus x squared. Okay. Now it tells me that when y is 2, x is 1. So let's sub that in. We have ln2 plus c equals ln1 minus 1 squared, which is 1. So c equals ln1 minus 1 minus ln2. Okay. What I'm actually going to do is I'm going to bring ln1 minus ln2 would give me ln a half minus 1. Now, we tend to not have ln's of fractions, so what we can do is we can actually make this the same as ln2 to the minus 1, which is the same as doing minus ln2 minus 1. Pretty nifty, right? So now we have ln y then all of this stuff, we have minus ln 2 minus 1 equals ln x minus x squared. So that's what we have at the moment. Now, if I want my equation for y, I need to shove everything else to the other side. So let's do that. ln y equals ln x. I'm going to write the ln 2 next to it because it just makes sense. Minus x squared minus 1. So this is the same as, remember the product rule? So if when you minus two logs, you divide them. When you add them, you times them. So this would be the ln 2x minus x squared minus 1. Now I'm going to exponentiate both sides. So I'm just going to call it expo for now. So we have y equals, now you're probably looking at this and you're probably going to start throwing up violently. But what we can do is remember when you have your power laws, your indices laws, yeah? What we can write this as is e to the ln 2x multiplied by e to the minus x squared minus 1. So what we have here is 2x e to the minus x squared minus 1, which is completely fine. If you'd like, actually when I brought this over to the other side it should have been a plus 1, shouldn't it? So what we could do if we want to make it look slightly nicer is 2x e to the 1 minus x squared. Looks a bit nicer, not strictly speaking necessary. Both of these are correct, once you've changed it to a plus of course. But yeah, that's it for 6 marks. Again, that didn't take me too long, so hopefully you can see that although they are a bit tedious, they're not the worst things in the world. Okay, so next we have dy by dx, etc, etc, etc. So once again, since we have to times by dx, we want the dx is on the right hand side, the y is on the other side. So without even thinking, let's just get that done now. So again, I'm going to leave the fractions separately because I want to. Now, I need to do partial fractions on the left because you can't integrate like this. So what we're going to do is we need to factorize this first. So that would be 3y plus 1 and y plus 3. So now if I write over here what I'm going to do with our partial fractions, and again laying out your work nice and neatly also does help, not just for your sake but for the examiner's sake as well, because keep in mind they're the ones marking your work. You need to make sure that they have a good time. Y plus 3. Okay, I'm going to try and not make any mistakes. So again, I'm timesing through by the denominator on the left, so 3y plus 1, y plus 3. So I have 1 equals a y plus 3 plus b 3y plus 1. And if I were to solve this, or attempt to solve this anyway, we have, let's sub in the y equals minus 3 first, because it kind of makes sense. We have 1 equals, the a term goes away, and we're left with minus 3 times 3 is minus 9, plus 1 is minus 8, so we have minus 8b. So b is equal to negative 1 over 8. Easy. And then we have to sub in minus a third. One equals, okay, so minus a third plus 3 would be 8 over 3a. So, sorry, negative 8 over 3a. Oh, no. Just a over 3a. So then a is just equal to 3 over 8. Cool. Which means we can now sub this all back into our original partial fractions expression in order to make our lives ever so slightly easier. And I'm going to have an integral sign as well. So we have a was 3 over 8 3y plus 1. And technically we should maybe leave them factorized out, but too late. 1 over 1 plus 3. X. Okay, now I'm going to pull out 1 over 8 to the other side, to the outside, and that should help us out. Yep, that'll be the best thing to do. And another thing you can do, by the way, is instead of, if you look at this and you think, oh, that's a bit spooky, you could write a dy after here, then another integral sign and a dy later, right? Because that gives you the same kind of result. So feel free to kind of break them up into multiple little bits. And so, for example, if I were to do that, I could have 3 over 8, 1 over 3y plus 1, dy. Then minus 1 over 8, 1 over y plus 3, dy, equals 4x squared over 2, so it'll be 2x squared plus c, right? That gives me the same result as doing the whole thing in one line. So I'll do it this way just to make it a bit more, just to make sure you kind of get it. Now the first thing we integrate, so we're going to leave the 3 over 8. And remember what I said, you do ln 3y plus 1. So you do ln of the function over the differential, which is 3. And if you notice, you can cancel out the 3's. Minus, you still have the 1 over 8. And then you have ln y plus 3 over 1. So cancel the 1's, right? And you're left with 1 over 8 anyway, equals 2x squared plus c. So what we can do is, since we have 1 over 8 for both of them, we could actually combine them. Actually, you know what? Let's do the first things first. If we go back up to the beginning, it says y is 1 when x equals 0. So let's work out what c is first. And, whoops. So we have 1 over 8 ln. 3 times 1 is 3, plus 1 is 4, right? So into this bit. Minus 1 over 8 ln 1 plus 3 is also 4. So those two cancel, that's very nice. And then we have 2 times 0 squared plus c. So this all cancels. This is obviously 0. So c is 0. We don't have a constant of integration. Cool. Keep in mind that doesn't mean you're wrong. There are plenty of expressions like f equals ma that when you integrate to find f equals ma, there is no constant of integration. There's not always a plus number for every single equation that exists. So what I'm going to do now is, back in the original thing here, I'm actually going to combine them into one big logarithm. 3y plus 1 plus 3 times both sides by 8 exponentiate both sides times both sides by y plus 3 it's a fun one, right? And we can keep going, so we just need to find our expression. So y e to 16x squared plus 3e 16x squared. Bring all the y's to the left hand side, everything else to the right. So we have 3y minus y e 16x squared equals 3e to the 16x squared minus 1. Factorize out the y. And there we have it. No logarithms. Easy peasy lemon squeezy. So I hope you enjoyed that. That is basically the differential equations topic summed up. Again, you can see that they are worth a ton of marks, and they do come up very, very frequently. So just make sure that you kind of practice them. The method is basically the same, right? You may have noticed I picked 3 completely separate questions, and yet I did very similar things. I had logarithms, I had exponentials, moved everything to one side, etc. So these things are quite common. But yeah, I'll see you in the next one.